Alrighty, what's going on, guys? It's Professor Kirk here, back with another video for you all. Just as a reminder, these videos just brought overviews of the concepts and major ideas that we learned in the class. If you have any questions about the details, please feel free to reach out to your professor or to your graduate student. Alright, so let's get into it. Today we're going to be talking about energy expenditure and fatigue. And we're going to look at a little bit about the measurement systems and how it's evaluated and how energy is actually expended in terms of exercise physiology. So with that, let's begin. What is direct calorimetry? Cannot say it, but that is besides the point. So what this is, it's just a measuring system used to determine ATP use through heat release. So if you remember earlier in the semester, we learned about how ATP is the main energy source or fuel source of the body. This direct calorimetry measures this through heat release, because ATP, if you haven't taken biochemistry or general biology, you learn that it gives off heat in the process of it being formed. So with direct calorimetry, what we do is we have a person, they're exercising inside this chamber, and there's water, which is in the blue, outside the chamber, and the heat is given off, and we measure that, and we're able to correlate that essentially with the ATP production or the ATP usage. Now, stepping away from direct calorimetry, let's look at indirect calorimetry. What is this? How do we measure that? So I don't have a picture up here, but what it is essentially is you have a person like on a treadmill, very much like in this situation, but they're not in a chamber. They're not surrounded by water, and not everything's contained. What it is, though, but they have a mask on their face, and they're looking at the VO2 exchange. So what that is the ratio of O2 inhaled to the CO2 exhaled. And what we're looking at is we're looking for the amount of O2 in particular. And we measure this O2 in terms of liters. And 1 liter is equivalent to 5 kilocalories. So from their exercising, we're able to determine how many kilocalories have been expended and how much energy has been used overall. Now moving into the respiratory exchange ratio. Let me set this down first. All right, respiratory exchange ratio. This directly correlates with what we talked about over here in direct calorimetry. We're looking at the O2 inward inhaled and the CO2 released. And the respiratory exchange ratio, this is essentially the exact equivalent. So we have the CO2 exhaled and the O2 inhaled. Now this is a quotient that yields something called the respiratory exchange ratio. Now depending on the number that you get from this, let's say for example we had a RER of 0.7, this would tell us that, alright, more fat is being used. And this is a scale that has been developed over scientific research and stuff, so don't worry too much about like, oh, how do I figure out if more fat or more glucose is used? If you look at the chart within your textbooks, they can tell you this. Well, let's say if we have a RER of 1. This means that more glucose or glycogen is being predominantly used in our energy systems when we're doing exercise. Moving on to our next measurement of exercise physiology, we have isotope measurements, which is looks at these. We have elements that are normal, but then we have these ones that are abnormal. They have different weights, and those are called isotopes. Now with these isotopes, what we'll have is somebody drink like a special drink, essentially, and we'll look at the measurement of their metabolism through that process. That's one that you're really not going to need to know for the test and stuff, but I thought it'd bear mentioning because it was in your textbook. And moving on to the final 2 sections of this video, we have our basal metabolic rate and our resting metabolic rate. Now with our basal metabolic rate, this is the energy expenditure at rest. So when you go to sleep and you've been sleeping for 8 or 12 hours, your body is using the minimum required energy to survive. Now this means that it's using the least amount of calories, the least amount of metabolism, the least amount of everything, and like the least amount of biochemical processes, the least amount of every single thing that you can think of in your body. Now with this, what we're able to observe is how much, or what is the minimum, I guess the minimum use or minimum quantity that is needed for someone to survive essentially. Now on the opposite end of the spectrum, we have the resting metabolic rate, which is energy expenditure this is that you use when you're awake. So this is like when you're walking and you're talking and you're going about your regular daily life. This is that energy expenditure. Well, that concludes everything for that video, and I hope that it was helpful.